Okay, moving rapidly on now with our vectors course, and we're going to look in this screencast at unit vectors and at addition and subtraction of vectors. Okay, so firstly, unit vectors, we know I and j to be the unit vectors in a horizontal and vertical direction, respectively. Well, unit vectors more generally are just vectors of 1 unit in length. So vectors of 1 unit in length. So that can be in any direction. So for instance, we're going to look at a question, vectors of 1 unit length like so. So an example here, find the unit vector in the same direction, as, let's go with, say, just pulling this 3i plus 4j. Okay, so find the unit vector in the same direction as this. So 3i plus 4j, we know is 3 across and 4 up, isn't it? So we're going 3 this way, and we're going 4 up this way. All right, and that's the vector there. That's 3i plus 4j, that vector there. Now, the unit vector in that same direction. So we're looking for a unit vector in the same direction. Let's think about this. What is this length? Because we just want one of them, right? We just want to know what one of them is and what that there is. That's the unit vector. Unit vector in the same direction as 3i plus 4j. So what is that length? Because if we find that length, then we can say, well, this is 1 over that length. If that makes sense. If this is 5, which it is actually 3, 4, 5, then this will be 1/5 of 5. So 1. So this the length of this vector. So the length of 3, 4, or the distance of it, or the magnitude, is equal to 5. So therefore, our unit vector is 1/5 of the 3, 4 vector, which in unit vector form is 3/5 I plus 4/5 j. So the key is to find the length, and then 1 over that length times the vector that you started with will be a unit vector in that direction. So let's have a look at another example. So B, let's have a look at find a vector of length 10 in the same direction. So this is not now find the unit vector, it's find a vector of length 10 in the same direction as 3 minus 1. So what are we going to do here? So 3 minus 1 means go 3 to the right and 1 down. So it's something like this. 3 to the right, 1 down. 3, 1. Now this length here, that's the length of 3, 1. Distance of 3, 1 is the square root of 10, is it not? 3 squared plus 1 squared. So we want what's the vector that's 10 units here? Well, why don't we find out the 1 unit? Why don't we find out the unit vector, which is going to be equal to 1 over the square root of 10, because 1/10 of root 10 is 1, so that's 1 unit in this direction. So it's 1/10 by 3 minus 1, and then if we rationalize the denominator, we get root 10 over 10. Sorry, we get root 10 on 10, so we get root 10 over 10, sorry, that's right. Root 10 over 10, 3 minus 1. So that's the unit vector. That is 1 unit long right there, but we want the vector of length 10. So the vector of length 10 in the same direction, So we multiply this by 10. We've got the unit vector. It makes sense, doesn't it, now to multiply by 10? And doing so gives us this vector right here, root 10, 3 minus 1. Excellent. Okay. Moving on to addition and subtraction of vectors. So if we wanted to have a look at, let's say, addition and subtraction. So let's say we've got A equals to 1, 2, and B is equal to minus 3, 0. Then what we've got, let's draw these out. So we've got 1, 2, so 1 across and 2 up. This is A going that way, and B is minus 3, so it goes left, and then that's it. So it's just horizontally left, and this is B. Now when we look at A plus B, so these are the two vectors, A plus B, what we end up doing is we take A and we put B on the end of A. So we take this B here and we pick it up and we drop it on the end of A. So we pop B there like this. Okay, B represents this minus 3, so it's gone along 3. This represents 1 across and 2 up, so that distance is root 5. But what we've got, A plus B, the result of A plus B is equal to that vector there, from the where you started, where A started, and where B finished. So A, you join the tail of B up here with the arrow of A, and you continue, and then AB, A plus B, this is A plus B here, this red vector, that's A plus B. Now it won't surprise you to learn that A plus B is just the sum, 1 minus 3, 2 plus 0, minus 2, 0. So that is, sorry, minus 2, 2. I've said 2 plus 0 is, 2 plus 0 is 0. So I'm struggling there. 1 minus 3 is minus 2, so minus 2, 2. So probably, even though my diagram is not great, we can probably believe that this has gone 2 to the left and then 2 up. We can probably believe that, can't we? So that works. What about subtraction? Well, let's say we take, let's take B and subtract A. Okay, so what we've got now is B, which is minus 3, 0. And if I just draw my diagram for B, that goes that way. Now minus A, so what 1, 2 went 1, 2 like this, went that way, so minus A is going to go this way. So we're going to go down here like this. So this is minus A, it went left 1 and down 2. Now my resultant vector is this vector here, which is called B minus A, because it starts here at the tip of B and ends up at the arrow at end of minus A. So that from there from start to finish is my B minus A. So you can see the trail there, B minus A equals that. It's the same as this vector here was A plus B. So where from beginning to end, that vector equals that vector plus that one. This vector here is equal to this vector plus this vector. So B minus A, let's use our vector arithmetic here. That's going to be equal to B minus A. So it should be B minus 3 minus 1 and minus, so B minus A minus, so minus 3 minus 1 and 0 minus 2. So minus 4 minus 2. Let's see, does that sound right? Minus 4, yeah, that looks right. Minus 2, that does look okay. So that works just nicely. So one more example. 3A plus B, and that will just be 3 times the length of A, and then you add a B on the end, but it will just be 3, 6. So it's 3, 6. I just multiplied my A vector by 3, 3, 6, plus B, which is minus 3, 0. And 3 minus 3 is 0, 6 plus 0 is 6. So there's my 3A plus V vector. Okay, as it says in the title, 12 F and G are now ours for the taking, and look forward to getting on with those. See you soon.